In this standard, we're going to learn about graphing linear inequalities. First, we'll graph them in one variable on the coordinate plane, and then we'll graph some two-variable ones, and we'll solve some real-world problems. So first of all, let's look at this inequality, x is less than 4. So we've graphed things like this before, just using a number line. We went to 4 and we made an open circle and we shaded everything to the left. We're going to do something sort of like that, except now we have this whole plane to take care of, not just a number line. So I'm going to 4, 1, 2, 3, 4, and instead of making an open circle, I'm just going to put a dot here. Now on the coordinate plane, there's a whole bunch of points that have an x of 4. There's not just that one, also that one, and that one, and that one. Everything up here, everything down here. So I can graph the line x is 4 by making a vertical line. Now, same as I did the open circle on the number line, instead of making a straight solid line, I'm going to make a straight dotted line, best as I can with this pen. So here we have sort of a dotted line. And now, once again, I'm going to shade everything to the left, except instead of having a straight line, because I'm in 2 dimensions, I'm going to have a plane. So here's everything to the left of an x of 4. Now let's do y is greater than or equal to -2. So I'm going to go down to -2 on the y-axis and make a dot. And once again, since I'm in a plane, there's a whole bunch of points that have a y of -2. All those ones, all these ones off to the left. And I'm going to connect these with a line. Now this one is y is greater than or equal to, so that means I include everything. So same as making a solid circle on the number line. I'm going to make a solid filled-in line here at y is -2. I want y to be everything greater, so I'm going to shade up, because this is all of the y's that are more than -2. Let's graph an equation. Y minus 4x is greater than 6. I'm going to graph this one in slope-intercept form, so I'm going to add 4x to each side. And I get y is greater than 4x plus 6. So I have a y-intercept of 6. 1, 2, 3, 4, 5, 6. And I'm going to go up 4 over 1. 1, 2, 3, 4, 1. I'm also going to down 4 over 1 to the left, so I've got 2 points. And y is greater than. So this is a case where I'm going to use a dotted line, not a solid line. So that's y is greater than 4x plus 6. Now, to do the shading, I need to do everything that's greater than that. So I'm going to think about all the y's that are more than. That means I'm going in the up direction. So I'm going to shade this way. And that's the graph of the inequality y is greater than 4x plus 6. Next, we'll look at an inequality that's been graphed and see if we can go backwards from the graph to the equation. First, we look at the equation of the line that's on the border of the graph. So that would be this right here. So I'm going to look and see the y-intercept and the slope of that, similar as I did back in the section on graphing straight lines. So the y-intercept of this line is 2. And I'm after the equation in slope-intercept form, so I'm going to need the slope also. So I'm going to start at a point that's on the grid. The y-intercept's the first one. And then let's look and see where this line crosses the grid again. It looks like it's going to cross it here, and it looks like it's going to cross it here. So let's figure out what the slope is from those points. To get from the first point at 2 to this next one, it looks like I go down 1 over 2. So that means the slope has a rise of -1 and a run of 2. So the equation on the border of that line is going to be y equals -1/2 x plus 2. Now I need to know about the shading. It's a dotted line, so it's going to be a greater than or a less than. And the shading goes above, so that's going to mean greater than. So the equation of this line is y is greater than negative 1/2 x plus 2. Next, let's do a little application problem. Bananas cost $3 per pound, and strawberries cost $8 per pound. If you want to spend $20 for fruit for your smoothie stand, what possible mixtures of fruit could you buy? Same as I did with equations and word problems, I'm going to define some variables. So B is going to be the number of pounds of bananas. LBS is abbreviation for pounds if you haven't seen it. Pounds of bananas. And then S, I'm going to have be pounds of strawberries. So the money I spend on bananas is going to be $3 per pound times the number of pounds I get. And the money I spend on strawberries is going to be $8 a pound times the number of pounds of those. So if I add the money on bananas and the money on strawberries, I need it to be less than or equal to $20 because that's all I've got. So I'm going to graph that, and then this graph is going to show me how much I could spend on each one. For graphing this equation, I think putting it in slope-intercept form is going to be kind of awkward. There's a lot of fractions. So I'm going to graph it with x and y intercepts instead. I'm going to call the x-axis the banana axis. And I'm going to call the y-axis the strawberry axis. So first, let's find the banana intercept. So 3b, I'm going to put in 0 for strawberry. That'll give me the banana intercept. And that's going to, I'm just going to say equals because I'm looking for a point, 20. So divide each side by 3. So 20 divided by 3, how many times does 3 go into 20? 3 times 6 is 18, so that's 6 2/3. So this line's going to cross the banana axis at 6 2/3. 1, 2, 3, 4, 5, 6. A little bit more, so about there-ish. And for strawberries, I'm going to put 0 in for bananas, so I'll get 8s is less than, well, I'm doing equals, is equal to 20. Divide each side by 8. So 20 divided by 8, that's about 2. Well, first let's reduce it. 2 goes into each of those. So that's 10. Actually, 4 goes into each of those. So that's 5 halves. And 5 halves is about 2.5. And actually, it's exactly 2.5. So on the strawberry axis, I'm going to go up to 2.5 and put a little dot. So I can connect those two, and that's going to give me my line. Do I want to use a dotted line or a solid line? I'm going to go with solid because I've got that equals. So there we go. And the amount of money I can spend is less than 20, so I want everything below. And that's going to be all of these guys. So let's look at this graph a little and see what it tells us about the bananas and strawberries we can buy. It doesn't make much sense to buy negative pounds of bananas or strawberries, so I only want the positive parts. So it's just this triangle in here. It's the possible strawberry and banana weights I can get. So let's pick a point in this triangle, like this one, for instance. 1 pound of bananas and 1 pound of strawberries would mean I spent less than $20. 2 pounds of bananas and 1 pound of strawberries means I spent less. Any point that's inside of this red triangle, if I look at the banana coordinate and the strawberry coordinate, those are possible weights of bananas and strawberries I can buy and still spend less than $20.